We have an abstraction for consumer behavior. It's called the demand curve. We have the same for firm or producer behavior. It's called the supply curve. And we want to now look at equilibrium in a market where we have such of these constructions. So let's draw them out. On the horizontal axis, we're measuring quantity, which we represent by Q. On the vertical axis, we're measuring price, P. We have a demand curve, which we'll call D0, the original demand curve. And we have a supply curve, which we'll call S0. Again, the supply curve represents how producers will respond by putting certain amounts on the market. Higher prices up in this range, lots more output. Lower prices, not much output. Same for the demand curve, except it's now inverse. Higher prices, people don't want to buy as much. Lower prices, people want to buy a lot more. Recall what we're trying to discover here is we want to figure out how markets make allocation decisions. Prices are rationing devices. We're going to find a price which basically rations the output across these consumers. So that price quantity combination, I think most people would expect that that's at this intersection. And that is in fact correct. We'll call this P sub E, and we'll call this Q sub E. What we want to do is we want to discover something that economists call equilibrium. It's fundamentally important to our understanding. Equilibrium, for us, it's a very simple definition. No tendency for change. If you're in a physics class, they talk about equilibrium, they take a cereal bowl and they put a ball bearing at the bottom of it. It's just sitting there. That's an equilibrium. If you bump the bowl, the ball bearing will be rolling around and rolling around. It's in an out of equilibrium situation. Eventually, it will rest again at the bottom of that bowl. That's equilibrium. No tendency for change. Of course, conditional upon some external shock. That's what we're looking for here. Is what's the price that once we arrive at that price, there's no tendency for either party to change what they're doing. I wrote down that that's the equilibrium price, PE and QE. That's our equilibrium. And in order to believe it, we have to think about proving it. And so the proof we're going to use, most people when they hear proof, they say, oh, I don't like to do proofs. Well, this is a simple proof. It's called a proof by contradiction. Suppose I told you that the price was instead some arbitrary price lower than P sub E. I just arbitrarily picked that P sub 1. It's just some arbitrary price less than P sub E. At that price, we know that suppliers are willing to put alpha on the market, but consumers really want to buy beta. Now, that's an out of equilibrium situation. Consumers want more of the product than what the firm is willing to put out there at that price. Economists have a name for this, not very clever. We call it shortage. Shortage is an out of equilibrium situation. Something's got to give. Remember, we talked about the fact that scarcity means there's not enough to go around. This is a situation where that arbitrary price I picked, P1, it's not doing its job. Lots more people want the product than the product is available. Again, we have an allocation problem here. The market's going to take over, and the market is going to do what? Well, the market is going to put upward pressure on that price. And as the market puts upward pressure on that price, two things are going to happen. One, firms are going to be willing to put more in the market at that higher price. Okay, that's helping to alleviate this shortage issue. Simultaneously, as price goes up, consumers want to buy less. Quantity demanded is falling. Those two things, the fall in quantity demanded and the increase in quantity supplied, are working to alleviate this shortage. And as you can see, this upward pressure on price will continue until price gets exactly here. Because any time that price was lower than that piece of E, there's still going to be some excess quantity demanded over quantity supplied. That's an out of equilibrium situation. There's still going to have to be a little bit price to go up to get just a little bit more quantity supplied and a little bit less quantity demanded to get to that spot. So that was a proof for us that no price less than PE could be in equilibrium. We have to finish our proof by contradiction by trying a second price. Let's try some arbitrary price P sub 2, which is above P sub E, and we'll call this point X, and we'll call this point Y. X is the quantity demanded at this high price, not very much. Y is the quantity supplied at that high price. Firms want to put a lot out there at that very attractive higher price. This gap, economists call by the name surplus. It's an out of equilibrium situation. Too much output's being put on the market, not more output than what consumers want to buy. Something's got to give, and that give is that prices are going to have to go down. Firms are going to run sales, they're going to give rebates, they're going to do all sorts of things to get rid of this extra product. And as that price goes down, once again, two simultaneous events are happening. As price goes down, some of these consumers are saying, you know, I want more of that product after all. Simultaneously, as price goes down, the firms are cutting back on their own particular production, stopping with all the extra inventory going. Both of these are working to get rid of this surplus, and as you can see, that reduction in price will continue until it gets right here. Any price higher than PE, you'll have production in excess of what consumers wish to buy, and this little gap, it's not very big, but it's still an out of equilibrium situation. Okay, so we've now come to a conclusion that the price will settle where demand equals the supply, and that price will clear the market. The amount people voluntarily wish to purchase is equal to what people voluntarily wish to supply. Now let's take a look at an example using that. Let's think about the market for orange juice. So we'll draw our axis system. On the vertical axis, we have price. On the horizontal axis, we have the quantity. And this is orange juice, OJ. We have an initial demand curve. We have an initial supply curve. And that gives us an equilibrium price and quantity. You know, it's $3 a gallon or whatever. There's some price and quantity in the market. Now, you get up in the morning for breakfast, you turn your radio on, you're having a cup of coffee, and you hear, or maybe you're watching on CNN, and you see these videos of orange groves in Florida with 1-inch thick ice on the oranges. And the very first thing you think is, oh no, the price of orange juice is going to go up. And that's true. We all lived through this many times, and this particular product happens every now and then when they have a freeze that's unusually deep, far southern Florida. This stuff happens. And as an analyst, which is what we're trying to get, an analyst, how would you show this price increase? Well, if neither of these curves move, then price isn't going to change. Remember, these curves, price wants to go. That's the equilibrium. It wants to go to the intersection of these curves. If neither of the curves move, there's not going to be any change in price. But we actually know what's going to happen. What's going to happen is that there's going to be a reduction in the supply curve. Why? Well, all that's left is the Texas and California orange groves. The Florida ones were wiped out by this freeze. So there's just not as much supply as there was before, the day before. If price tried to stay the same, look what happens. At this price, if price doesn't move, then suppliers are only willing to put out alpha at that price. Consumers say, well, I still want this amount because that's what I wanted yesterday at that price. My demand curve tells me how much I wish to purchase at that price. Out of equilibrium situation. More orange juice is demanded than can be supplied by the producers, given the loss of the Florida crop. What will happen? Well, we know what will happen. Price will be pushed up. And as price is pushed up, there'll be more orange juice coming out of the remaining suppliers. They'll divert some of their production from sort of just whole oranges to juice. At the same time as price goes up, some consumers will say, you know, I just don't need that orange juice. At this expense, I'll have, you know, diet soda for breakfast, or just drink water or something like that. This will continue until what point? Well, we know it's going to continue until we find the new equilibrium. Let's call this P1. That's a price high enough that, given the smaller supply of the remaining producers in the orange juice industry, the amount they're willing to sell at this high price is exactly equal to the amount consumers wish to purchase, the new equilibrium.